Okay. So for the ones who are the first appearing in this class today, so we are going to discuss data structures and algorithms in this course. I will tell you the paper code later. The paper code has been modified. Earlier it was OEME 391. So I will give you the updated paper code. So in the routine you will find OEME 391, the published routine, but it is updated now. No new nomenclature has come. Anyways, so what data structures and algorithms, this is basically a fundamental part. Okay, so as you know, when you do programming, you need some algorithm, or that means what you are doing basically with a programming, you are solving a problem, right? So for, as you know, that for any problem solving you need some strategy, right? So writing the strategy in sequence, in proper sequence, that is called the algorithm. Okay, say for example you want to go from, or you want to say algorithms, these are basically expressed as recipes. You will find in the books of algorithm that this is written or explained as equivalent to recipe. Recipe means what? Recipe means when you go for cooking, right? So what you do, you have some steps, right? So you have some ingredients, right? So ingredients are like say inputs, right? Next what you do, you go for having some steps, right? Preparation. So in the process of cooking you have some preparation, right? Mixing of some say going before going to even to the oven, you go for some mixing of, say there are some preparations like mixing of some spices, right? So marinating, etc. Different cookings are having different methods. So that means for doing something you need to know some steps, how to do it. So writing those things in steps, so that is called the algorithm. So algorithm means basically the process, okay, in proper sequence. Okay, so that is algorithm. Now what is data? Data means basically the information, right? Information. Say for example, what is your name? That is a data. Where is your home? What is your phone number? What is your class roll number? What is your voter ID number, right? Alphanumeric number. What is your Aadhaar number? So all these are basically information and these are basically data. So these data, or what is your uh, weight, right, height, etc. So some data you will find that, some data you will find that these are having integer values, right? Some data are having some fractional values, right? Say for example, what is your power of the eye, right? So it is not always integer, right? It has some fractional value. So what is the distance? Distance will be generally in fractional values, right? So these are the thing. Aadhaar number, it is integer, right? It is not fractional. So some data are basically integer, some data are having fractional value. Say voter ID number, say this will be say having some alphanumerics, right? So this is basically a character, right? So it can be treated as character. So like that. Basically these are data, means information. Now during problem solving, we may have different problems, right? We may have different problems, and accordingly we will have a particular data is structured in a particular way. Okay, so that idea is called the data structure. Data is something, now structuring the data in a particular format or particular way so that you can use it. You means the program, you can use it or you can store it, means using for what? storing for what? You want to store it for further use. Say for example, if you get a file of some data, if you do not know how this data is actually stored, you cannot understand it, right? You cannot use it, right? There is for example, there is a row and there are several rows, right? So these rows are meaning something, right? Say for example, your say class record, okay. Say for example, you are having in autonomous, you will have in a theory, you will have say your name, then you have roll number, university roll number, right? Roll number, then you have say CIA, right? CIA means continuous internal assessment, CIA 1, CIA 2, then you have end semester examination, right? EAC, then you have say attendance marks. So I should write attendance marks here. So I guess attendance marks is a component, so attendance, and then EAC, uh, EAC, so attendance, right? Then EAC, then total, right? This is in terms of marks, then it will be converted in a particular scale of say called SGPA, semester grade point average, like that, okay. So that will be basically a particular, this is called a record, a particular student, this is called a record. So say for example, name 1, I am not writing exactly the name, so name 1, then accordingly university roll number 1, then data, all these are there, okay. So this one is called a data, information, right? This is called a record, and all such records comprising, it is called a file, okay. So this is a particular data. So for a particular student, this is called a record. You will see that there is it is said that what is the record of the student, that means this is a particular record, right? So again you have such things for other students, right? So these are all records of different students. The students are identified by their key. There will be a key, right? Either his or her name or roll number. So it should be unique, by which you can identify the student. So like that, so university roll number, it cannot repeat. The name can repeat, right? Same name can repeat, Rahul Kumar, right? Same name can be there, say 3-4 students having the same name, but university roll number cannot be same, the same number will not be allotted. So university roll number will be a unique number, and that is basically the key, that is called key. So how to search that? So that is key. For example, if it is Rahul Kumar, by which name I can, if I search, then it may be say 3-4 number coming, 3-4 such records coming. So I have to know which Rahul Kumar I am trying to search. Therefore university roll number is basically the key. Key means that key parameter or key information by which I want to identify specifically which particular person I am trying to search, okay. So is it clear? Therefore, so it is a file, and then in the file you have many records, and in the records you have many information. Okay, these are called data. So some data are say character data, string, some data are numeric data, right? Some data floats, right? So I integer, character, float, right? All the type of data are there. So these are called data types basically. So data, and we have basically data type. So data has a type. Okay. Now data will have now see, you will see that data means basically you know by some name, right? So it is roll number. Roll number of what? Roll number for this student. So you have say a written file by hand, right? By record it is kept by handwritten file, right, in a particular register, right? Now when you actually make a programming or write a program, so what you have to do is you have to write a particular name for that data. So that is called the variable. So data is identified by some name. Okay, say name. So name of what? Name of this student is this. So that is the value, but it should have a variable. Value of what? Say your name. Say for example your name. What is your name? So I ask your name. So this your name term is a variable. And what is your name? Devargo. So Devargo Mollik. Now see, your name is a variable, right? So when I ask what is your name, that means your name, say your underscore name. Your name is a variable. And what is the value of that variable? Devargo, right? So it will be basically I কে লেখো নাকি CK লেখো, okay, Devargo Mollik. So this is basically a string, means character, right? So different characters and many such characters written together, this is called a string. So this is a basically variable of character type. Okay, so all these are characters. So your name is the variable, that is the variable. গ্রিনটা বোঝা যাচ্ছে? বোঝা যাবে না, ঠিক আছে। This is the variable, right? Variable name, and this is the value of the variable. Okay, say for example, what is the university roll number? So when you write this, this is called assignment statement. Assignment. This is called assignment statement. In programming, there is a part called assignment. Assignment means what? Your name can be Devargo Mollik, your name can be Nilotpal Ojha. So sometime it can be for this record, it is say Devargo Mollik for this record. For this record, your name changed. It is changed. So it will become Nilotpal Ojha. For this record, it will become Shubham Mollik. Right. So as you see that as you traverse, so the variable name changes. Accordingly, their records, different values of the fields. These are called the fields, right? Fields or data. So different fields will also change according to the name. Sometimes occasionally they may be same, like CIA1 marks may be same for 2-3 students, right? It can happen, but generally that is changing, we have to consider. Clear? So that means what, we have to take different names for this, otherwise they will overlap. When I will call, then I will get different value, right? As I store some value, but when I call, I will not get the value, because say in the same name if I store, that means what, it is overwritten. I have written somewhere, then I am writing on that only, so it will change the earlier value, so overwriting will take place. তাই না? তুমি যদি একটা খাতায় if you write some name তার উপর আবার যদি নাম লিখে দিই, কি হবে? ওটা বোঝা যাবে না, প্রথমেরটা সেকেন্ডটাও বোঝা যাবে না, কিন্তু কম্পিউটারের ক্ষেত্রে কি, it will be overwritten, right? So it will take the latest value, last value what is stored, right? So if I want to know all the values, then I have to store it in a particular way. So your name, therefore your name cannot be a particular variable, so I will come to now a variable which is called a derived data, that is called array. So particular value, particular name, but now your name will be stored like, for one record your name variable name is okay, but for several names what you have to do, you have to write like your name, then like this, okay? There will be one index. So say for example you have a serial number here, say 1, then 2, like that, serial number. So here there will be one index which will basically refer to the number of the row. So for a particular number 1, so your name means the name of the first student, so it will be say 1. For this record it will be say 2, for the third record it will be 3, like that, okay? So we can write it like I, where I is an integer. This cannot be a fractional value or float, clear? Because this is a number by which you identify. So a student location cannot be 1.5, right? It is either 1 or 2 or 3, like that, whole number. It cannot be fractional, clear? So therefore it is called the index of the, this is called a array data structure. This is called an array data structure. So that means what I understand is, you have a particular field, right? Now this field, if it is only one record, then I can simply give the name as this one, but if I have many such records, then simply giving the name is not enough. We have to know which, otherwise what you have to do, you have to go for so many variables, so many variable names. Say you can write, instead of your name I, here you can write like your name 1, then your name 2, your name 3. So what will happen, basically there will be so many variable names. So what is the problem? When you write the program, you have to write a fixed value 1, 2, 3, like that, and in that case running the program in a loop will become difficult, okay? So you cannot use 1, 2, 3 different values for the program. So to make that convenient, what we do, we write it for different, that is this as a different identifier, so that we can use it for writing a loop. Loop means what? So the same thing we will do, right, just by calling this value, okay? I is equal to 1 means first student, I is equal to 1 means second student, Now if I write like this, there will be a problem because this is considered as a string. Now therefore 1 cannot be considered separately as a value. Okay, so there may be some mechanism by which you can write like the first uh, part is this and the second numeric value is the number, but that becomes a complicated programming, right? So to make that convenient, what you can do is, that means first this is the string part, okay, or this name part in that case is the variable name, and this is the identifier for the location, particular serial number. Okay, so that is the simplest data structure, that is called the array data structure. So what you understand is that when you store a structure, you are storing basically in a structured format, right? So how you actually store, you write this, then when you call it, then you get this, then for that I, you see that same I is used for this, all this, clear or not? So this is name 1, then I is equal to 1, name 1, university roll number 1, CIA marks for the first student, CIA 2 marks for the first student, like that, attendance, ESC, total. So I is a common identifier for all these, right? That means you can use it wisely, you can use it very effectively. I is equal to 2 means for this record, for all, that means all the elements or fields of the second row, you will use I is equal to 2. Mean in C programming, the first will be used as 0, then 1, then 2, like that. Okay, there is a particular default setting, that means in the array the first is identified with 0 and then 2, 1, 2, 3 up to whatever be the number. So starting count is 0. Okay, this is a default. Although you can set a default set a particular starting counter. Okay, you can start with 1, 2, 3, 4, anything. That means these are in the array, there will be a lower bound and upper bound. Lower bound means what is the value with which you are starting, and another value where you basically terminate. So lower bound, upper bound. So that means by that way you can definitely change the lower bound setting from 0 to some value, other value, right? But default we will use, otherwise we have to write a particular set of statements, right? The part of the program will be there. So default is 0 as the starting or the lower bound. Okay, is it clear? So therefore do you get some idea about the means data structure? Okay, now this is a particular record. Okay, now there are different data as we come across in our life, right? Some data you will say group data, like say name will have say 3 parts, right? Say first name, middle name and surname or last name. So you see that the particular field you have different parts, right? 1, 2, 3. So in other records, such records also, like for example address, right? Address, you will see that there will be several parts like home number, right? But street number, then there will be the local address, like say municipality, or say for example your uh, that is called district name, then street name, then district name, right? Local post office name, right? Then you have basically state, then you have basically country, like that. So address is a common variable, is the means the total or the one variable, but it has different components. So that is called group variable. Okay, now therefore when you basically say for example uh, uh, say different other data structures are also there. So this is called the array data structure. This is called the array data structure. Now this is called linear array. Simply one value we have taken, right? I. If you have many say I should say multi-dimensional, then you will have accordingly number of indices increasing. 2-dimensional, 3-dimensional, etc. Number of indices will increase. So for example, if it is 2-dimensional, then say 2D, say array B, say for example, I will write like I j. In C programming, we will write like ij. Say for example, when we go for matrix, right? Matrix, say for example, I ask you to solve a matrix multiplication. So A, B are two matrices and the product is C. So therefore, uh, I ask you to do a matrix multiplication for a two-dimensional array, means two-dimensional arrays. So matrix multiplication, it is not always that it should be two-dimensional, it can be other dimensional also. But say for example, I ask you to multiply two-dimensional arrays and the product will be also two-dimensional. Okay, so we'll go on. Okay, so two-dimensional ij. It will be written like B. What is the name? B is the name of the variable, and these are indices. So this is the row index and this is the column index. Clear? So this is two-dimensional. Next, you can have other dimensional. So accordingly, the index or indices will increase. Okay, it will add up simply. That is structure. In some programming, you will see that it is simply written like say B I J. So that is particular syntax for the particular programming language. Okay, so I J, how it will be written, that is for a particular programming language. That is, there is no fixed or universal format for this. Okay, but for C programming we have basically square bracket and the indices are separated, means one square bracket will contain one index, next square bracket will contain the next index. Okay, that is the syntax particular. So when you will do it, then you will means over practicing you will memorize that. Okay, one thing. Clear? So there are other data structures also. As we come across different types of values, there will be different types of data structures. Like say for example, uh, we will see how the data are stored. Uh, we will discuss those. So one is called linked list. Another is called tree data structure. Another is called graph. So array, linked list, tree, graph, etc. The array we have discussed. Linked list basically when you have say some, for example, some records are repeated. I will give basic notion to that. Before that, I will discuss what is called a pointer. Okay, so you have seen that say for example, I write in C int x is equal to say 5. Follow the syntax properly. So int x is equal to 5. So that is an assignment statement. this is declaring, this part is declaring that x is an integer, so it will be written as int simply. Then x is the variable name, 5 is the value of the variable. Okay, so it is called, it is a data type. So it is declaration. Declaration part. Now this is called the assignment. Okay, now what is this? This is the variable name. Variable name will be basically alpha numeric. Alpha numeric means alphabet and numeric. So it cannot be numeric simply. So I cannot consider 1 as a variable. So I cannot write 1 is equal to 5. That will give error. Okay. You can write x1 or simply x, right, or xx1. But that numeric value or numeric part will be followed by the alphabet part. Okay. So that will be the type of variable. You can use underscore, right? You can use underscore x1 is equal to say 5. But one thing is the alphabet part will be at the starting, it will be the variable name will be initiated by the alphabet part, then you can have numeric part and say underscore part, etc. One thing. Another thing is you cannot write like x1. So there should not be any space between the parts of the variable name. So it will not treat these two as a single name. Clear? So you have to that means blank is not considered as a part of the variable name. So that will give error. So you have to either connect with this one or some other thing, or you have to delete the space. Clear? That is the way. So okay, another thing is when you have a program in C, there is a statement, this is called a statement, and in the statement it will be terminated or it will be ended with a semicolon. So that semicolon part means that the statement is complete. Okay. Statement is complete. So this is the termination of the statement. If you do not put that, then it will give error that that statement is not completed, that semicolon not found, like that. So this is required for terminating the statement. Now this is a particular type of statement, that is, these are called executable statement. Executable statement means what? So these are all executable statements. So what is the meaning? That when basically you are writing a program, what you are basically doing is you are asking the computer to do the job for you. Okay, that means you are not doing yourself, you are writing instructions, these are called instructions. So basically these are instructions, and these instructions you are giving to the computer, so that computer will do it for you. That is the meaning of program. So these are basically set of instructions. So according as you have written a algorithm, then you have a part called pseudocode. Pseudocode means it is not exactly code. Pseudocode actually is not followed by following a particular language. Algorithm means it is general, right? It is written in English, plain English. It will be statements, written the instructions. Everyone can read. Pseudocode means it is not exactly code, but it is like a code, like a structure of a code. It will be written in the format of a code, but it is not following a particular language, right? Pseudocode, that is called pseudocode. So first comes algorithm. Then you have pseudocode. Then you have basically the program or the code. Okay. Then you have basically the output. Okay. Clear? So pseudocode is basically in the form of a code, but exactly not written in a particular language. Right? So for example, when you write in algorithm, you write run that in a loop. You just simply write that, run that in a loop. But in the pseudocode, exactly you will write that loop for I is equal to 0, from this to this value you will do this, right? So but it is not exactly in a particular language like C or Python, like that. Okay, so that is a general one, but more like a structure, more like in the structure of a program than the algorithm. And program is finally it is in a particular language, so this is not independent of language, so you have to know the syntax, right? And output is what is the input according to what is the output from the program, so that is for testing, etc., right? So these are the steps how you do that. Now here x is equal to 1, so this is the variable name and this is the value, as I have mentioned. So this is the value of the variable. Value of the variable. Okay, now you see that these two things are there, you understand it. The x is the variable name and 5 is the value of the variable. But where that value, where that variable is there in the computer memory, that we do not know. Here we do not know that, or we have not written anything, any information regarding that. We do not know. So when the program, when you will write the program to use that information, where the program will search? Where in the computer the program, where from in the uh, computer the program will search? You have to know it. Say for example, you have been admitted in the college, you are coming, but I want to give some information to you. How to give that information? You have a, how to get that? I have either I have to email you, or I have to send a message to your mobile number, in your mobile number, or I have to send a letter to your address. That means this address is important. Mobile is also an address, but this is mobile, means you can move with the mobile, so mobile address, right? Earlier means when we used to use land phones, the land phones is situated in your home address, right? So whatever I do, if I want to reach you, I need to know your location, isn't it? You come to my office and to search me, but you don't find me, then what you ask? Where is the teacher, right? That means my location, you know, you need to know. If you want to get me, then you need to know my location. So here also location or address is important to get that value, they get that particular variable, right? So address is important. Now here this address, for this we define a pointer, right, or a value. Say for example, what is the address of this variable? So for that what we write is and x. This is called address of, right, address of. So this means address of, ব্লুটা দেখা যাচ্ছে, ব্লুগুলো দেখা যাচ্ছে, this means address of x, address of x. Okay, next we define a pointer. Say pointer can store address, or pointer will store address. So how to write that? So what I do is basically, say write this x is equal to, say int x is equal to say 5. So I know that x is an integer variable, x is an integer variable having current value 5. Okay, next is I declare that int star p. Okay, when I write like this, star means asterisk, asterisk. So that means basically p is a particular type of variable, particular type of parameter, that is called pointer. Okay, so this is, here p is a pointer variable. This is a particular type of variable. P is a pointer variable. That means what? It points to something. So what is that? Next, if I write, say p is equal to ampersand x. Now what I am doing? P is a variable. Like say, if I write say instead of this, if I break this into two statements, basically as I have mentioned that this is a combination of two statements. One is the declaration statement, another is assignment statement. Right, two parts are there. So here I can break it into two statements, individual. Okay, so I can write int x. Next I can write x is equal to 5. So I have now broken that means combination statement into two individual statements. This is the declaration part, this is the assignment part. Okay. Next, here also you see that this is the declaration part and this is the assignment part. So you see that x is a variable. It can store any value. X is equal to 5 is the current value. Similarly, this star p, that is p is a variable which is a particular type of variable called pointer. Now p can store any value. So currently this is storing the address of x. That is the meaning. You can store any other value. You can reassign any other value. Say for example, you have say x, int x and y. Okay. Now you can reassign say p is equal to ampersand y. You can reassign. So p is a variable like x and y. So as x can store 5 or any other value, similarly p can store the address of x or address of some other variable. Clear? So this is called the pointer variable p, which can store the address. So how to write that address? That means x is a variable. Ampersand x means basically in the C syntax, ampersand x means basically address of that variable. Like your name is Debargo. So if I write ampersand Debargo means where the value of Debargo is stored, or say ampersand kilo. ছটফট করো না, এতবার এদিক সেদিক দেখলে তো মাইন্ডটা ফ্লিকারিং হচ্ছে না। পেন নিয়ে টোকাটুকি করবে না, পা নাড়াবে না, এগুলো করবে না, ওকে? ব্যাড ম্যানার্স এগুলো, ঠিক আছে? সো okay, so address of means that particular address. Now in normal case address means your location, physical location, right? কি বলি আমরা, ল্যাটিটিউড লঙ্গিটিউড, তোমার বাড়ির লোকেশন। So that is the latitude longitude, you know, right? So how much in the east direction, how much in the north direction, your location, right? It is east and north in a particular Durgapur or Howrah or Kolkata, it is east and north. Similarly in computer it will have some address, right? So if I want to know the address, then I will write like this, and how what I am doing is I am storing it in a particular variable, that is that. You can use it like ampersand x, that is this, but when you have to use it particular in the particular variable form, then I will write like p is equal to ampersand x. So that means p is the p is storing the address of x. Okay, so it can be understood physically like this. Say for example, if you have a particular say book rack or some say chemistry library, chemistry say you have say chemistry laboratory, right? You have such racks, right? Okay, you have some bottles or some containers, right? Say for example, I'm showing some beakers, right? Beakers. So you have say many such divisions. I am showing you some matrix. Next, I am drawing such things like here is one, then you have someone here, another here, another here, another there, like this. Currently I am not storing all the means containers, I am just storing all the racks, I am storing some of them. Okay, so this is the complete space, complete say memory, in which I am storing at some locations. So these are different locations. Okay, now these containers are basically the variables, right? Now it can contain chemical element A, some chemical element like say it can contain say methyl orange, or for example it can contain octane, like petrol. It can contain say some some other components like say urea, right? So different chemicals can be there, right? So these are the values. Okay, so whatever say amount of that particular is the value, and variable is the container, and the location is the address. So you can see there are three things in this part. One is the address, location, where it is there. Say it is 1 1, so it is row 1 column 1. In that row 1 column 1 you have a particular container, and in the container it is containing a particular variable or chemical amount having some particular amount, right? So that amount is say this one. Now you can change the amount, you can add some quantity, you can take up some quantity, right? So variable quantity will change. The variable name is not changing, variable quantity may change. If you change that location will change, right? If you are asking different things, then you will have different variables, right? X, Y, etc. So this container is like the variable, the location is like the address, and the content is like the value. Okay. So these are the things. Now, so pointer is little bit clear, I think. So pointer is basically giving you the address, right? It is pointing towards a particular location. Okay. Now I will give some examples of this. When we will discuss them in detail, we will discuss their structures. So linked list means basically, say for example, you have a particular data. Particular data means, for example, there is a student list, and then you have basically a list of mentors. Mentors in your curriculum, there is a concept of mentor mentee, right? So means you will be assigned some mentor to whom you will you will go and report for particular purpose. Like say for example, you have some problem, you have some issues related to your curriculum, maybe some personal issues. So there will be MER point, then you will submit those MER point to your mentor, right? So these are there. So mentor, a set of students and their mentors. Okay. So if the students are there, that means student lists are different. All the students are different, right? But mentors will be, for some student a single mentor, then for some other student another mentor, like that. Okay. This is one thing. That means in that particular structure you have basically a particular variable for which some collections are there, right? Now, so how to know that which, say for example, this is very simple. That means for a particular group of student, if it is assigned from a particular roll number to another roll number, then the mentor is same. Okay, it is fixed, say for example. But if you have under a mentor, say first year student is also there, third year student is there, fourth year students is there. That means as the year goes on, some mentors, some mentees will be added, and some mentees will be graduated and their name will be removed for that particular mentor. Say for example, under my mentorship there is now third year students. Now as they will go into the fourth year, some first year students will come and they will be added under my mentorship. So there, that will be variable. So that will continue. That means under a particular mentor there will be many students. Okay. Now to know that, what we do basically, if I store like this, say for example, I have a particular student group and then all the mentors are written, then if I repeat the name, say for example, I have say total 40 mentee. Okay, total 40 mentee. Now if for all 40 mentee I write my names for all that situation, all that means record, I write my name, then storing the name takes a larger space, right? Also recalling becomes difficult. That means for my mentorship, how many students are there, right? So that becomes difficult. So what is done is basically, here the record is written for all the students. Now for the mentor is assigned a particular number. Okay, storing a number is more convenient in terms of space management, that means computer space management or memory management, than storing the name, full name. Okay, full name, if it is repeated for 40 times, it will take larger space compared to the number. So if I write the number instead of the name, then say for example I have a number of say 3 or 4, and the fourth I have been assigned the number 4. That means I have now, say by 3 can you know that this is my name? Okay, say you have been given a list, you have been given a list where your name is written, and in the mental list it is written 3. So how can you know that who is 3? It is not possible. That means there is another list required which will record that 3 means this name, 1 means Professor X, 2 means Professor Y, 3 means Professor A, like that. Clear? That means just by number you cannot know the name. Another name, another list is required. Okay, so that list will basically give you the set of mentors, and in your list of students there will be numbers. So that number will refer to that list. This student, the name of students, then there will be numbers. Numbers of what? Number of the professor. Now that is not complete. There will be another list which is basically only the list of faculties. Right? Now you have say 400 students, say for example. Say in your course you have say 60 into 4 means 240, 250 students. So for 250 students there will be how many faculties are there? 17. In our department 17 faculties are there. So for 400 students, 250 students, if I write the 17 faculties names, so it will be 250 times, it will take more space, right? So what we do, we write instead of numbers 1 to 17, enough. So storing that 1 to 17 more space means it will take less space, right? So space management point of view, it is convenient, or it is basically better. Now what we do, I write a faculty list where 1 means this faculty, 2 means this faculty, like that. Clear? Now that means what? Here this 1 to 17, that means for example under your, for your name the faculty number is say 10. Now you will refer that list to another list, that is the faculty list, where that list will be basically linked with that list. Clear? So there are two lists. One is the student list having some names and numbers. Now for that it will refer to another list which contains the list of faculties where you have the particular number, this name, this name, this name. So you are not repeating the names of the faculty here in that list. Only 17 names are there, and here you have 250 names. So there is no problem of basically that from the point of view of space, it reduces the usage of space. Yeah. So that is a concept of linked list. We will see the linked list in detail when we will discuss the programs. Okay. So that is one thing. Another thing is tree. Tree means what? Basically in tree, what is the meaning? There will be a root and then it will have branches. Okay, so it will start from the root and it will have branches. So for example family tree, আমরা বলি family tree, that means we have a great ancestor starting from that. Okay, whatever name I know, then from that there will be basically branches, means basically descendants, ancestor then descendants. So son, daughter, etc., right? There will be more and more descendants, right? So this is called a tree structure. That means when I want to store the detail of a family, which kind of data structure I will use? That is tree data structure. That is not particular array. Array means what? You have a particular record. That means one name, all one. But for example, one name, there are two sons. Under one name there are two sons. Then it will bifurcate, right? It will go on bifurcating, right? So tree is like that. So it will start here, then it will go like that. Then it can go only one. It may have only one. It may have 2 or 3, like that, right? So this is called a tree data structure. That means it will start at the root. This is called the root. Now it will have branches. Also there is one example for tree data structure, that is calculation of algebraic values. Okay, so for example, when we go for algebraic calculations, most of the calculations are basically binary. Binary means what? Basically operations are binary. Means I'm calling binary operations, means addition, subtraction, multiplication, division, all these are binary operations. Means what? It will basically, the plus is a operator. Say for example, if I write, say x is equal to 5 plus 3. What is the meaning? Plus is an operator and these are called operands. So 5 is an operand, this is an operand and operator. Operand, and this is the operator. So for this summation or addition operator, how many operands are required? Two operands are required. When you say put in calculator 5 plus equal, what will it will give? Error. 5 plus in a calculator, if I write 5 plus equal to, you will see that the calculator where you can see the operations, right? So plus also is seen. In normal calculator you don't see the plus symbol, but in scientific calculator what you see, basically say 5 plus is also visible. That means it is basically still accepting another operand. It is prompting for another operand. It is waiting for another operand to be given. So when I write 5 plus equal to, it will give error that it is syntax error. Okay, that means it is accepting, it is still requiring another operand. So this plus or addition is a binary operator which has two operands. Clear? So similarly, subtraction or difference is also having two operands, something minus something. So it will take two operands. Similarly, multiplication, two operands. These are all binary operators. Okay. So there will be other operators also, say means it will take three operands, right? We will see that. Now here we have basically in algebraic calculation also, we will see that, say for example, this is the operator, and it will take two operands, this and this, like that. So for example, if I write like say 2a plus 3, 2a plus 3, so it will be basically, so 2a is a operation, 2a means what? 2 multiplied by a is a multiplication operator, a plus is another operator, 3 is another operand. So this is a operand which is actually coming from a operation, and 3 is another operand. So how to write that? So you see that 2a, 2a, so this is a multiplication operator, 2 multiplied by a is a multiplication operator. After it takes place, what we do? Basically this is the result. Now what we do? We do plus with what? 3. Okay, so this basically is represented by a tree data structure like this. 2a, after 2a is completed, then it will be plus or added with 3. It is not like a plus 3 into 2. So operation must be understood properly. It is 2a, then that part product is added with 3. So this will give you the particular format in which the calculation is done in the calculator or computer, like that. Okay, so this is done with a tree data structure. So we have seen two such examples. Okay, now graph. Graph means basically in graph there will be two things. One is basically a node and another is basically edge. In a graph, basically how the things are connected. Say for example is social network. So you are one element, that is called node, another element, this is called another node, and your friendship, that is called an edge. So you are one, you have many friends, right? So you have many friends, for example. So this is all tree data structure. Next we will see the graph. Say for example different nodes are there, so I will draw it like that. Node, then node, then node, different nodes are there. Okay, so it may be connected with this way, it may be connected like this, it may be connected like this, it may be connected like this. Okay, so these are nodes and these are edges. Now these connections can be directed or undirected. Directed means if it is only this way, then it is directed. If it is both way, this is non-directed. Some example as I have shown you, say friendship. Friendship means both way. It is non-directed. That means you can send message to him or he can send message to you. Both way connected, right? So you can have two friends, but he can have three friends, right? This person may not have another friend than you, but this person has this friend, this friend. This person is only one, so it is only one, right? So another example can be, say, different cities. Like for example, I have told you that this is you, this is another person. So this can be cities also. Cities. So say for example Calcutta, Durgapur, or say uh, right, Durgapur, Calcutta. Then say for example a particular city where there is no much connection, right? Similar to this one. So you can have different locations or cities connected by transport or means transportation systems. Say maybe say by road, maybe by flight, etc. Okay, so different roads. So some these are all undirected. So you can go from this to this, and you can go from this to this. Both way possible. So this kind of cities connected is under a graph data structure. Another example can be এক মিনিট তাহলে এটা বলে দিলে সুবিধা হবে। Another common example for graph data structure is uh, website. Say for example this website has linked with this website. Some link is there. If you click this, then this website will open. From this website you may not come back to this. Maybe say from this you may not be able to come back to this. You can go means you can press the back key, but maybe from this to this you can go by a link, but from this to this you cannot go, right? So graph, this website is also one example of graph data structure. That means from this you can go to this, many links are there. From this you can come from this. Okay, so graph data, under graph data structure such examples can be used. That means what is the use of this data structure is that when you have many such data, how to use this data. Say for example, city location you cannot use in the array format. It will not be useful, it will not be convenient, isn't it? Some data will, some field will remain blank. Clear? If you use in the uh, array data structure this graph part, then some will be not required, right? So that is not actually proper way to store it, right? So if even if you keep some space but you are not using, that means wastage of space, and management of data is also not means convenient. Clear? So that way, that means how the concept of data structure comes basically. As you solve problems, then you understand that what kind of structure the data are, means what kind of structure the data are in which structure the data are there. So accordingly you define or use the data structure. So that is the concept of data structure. That means you have different problems, and in order to solve the problem, either you define a particular data structure, okay, or use the particular already there. Clear? So some, it may be linear array is okay. In some cases maybe a two-dimensional array required. In some cases it will not be, two-dimensional is not okay. You have to use more dimensional means array. In some cases linked list, in some cases tree, graph. Okay, according to problem you have to use a particular data structure. That is the concept of data structure. Okay, so we have given a means overview of data, then data structure, algorithms, and next we will be for a particular problem given, then you will write the algorithm, then you will use a particular programming language to write the program following the algorithm. Okay, so next we will give the problems. Okay, clear? Okay, thank you.